Hi future doctors, welcome to the next class. In this class, we will discuss about magnetic field B due to current carrying coil or circular coil we are going to say. So if we are taking one circular current carrying coil like this we are going to place. Okay, so whenever we are placing like this, so what is the magnetic field intensity at a distance x from the center we are going to calculate. So for this we require one formula. So the formula is going to be, we will take directly, and how this formula we are going to apply in our competitive problems we are going to discuss. I am not giving derivation for this because a derivation is not required for our competitive problems. So this radius is going to be r. If I current is passing like this, anti-clockwise direction, so now what is the magnetic field intensity at this point P? So current element they will take at a distance small r, that is going to be root of x square plus r square. So what is the formula means? On this axial line is equal to mu naught I r square by 2 into r square plus x square whole power 3 by 2. So this one you have to remember. How you remember so many songs? How you remember childhood ABCDs tables? All these same like that. If you recall 2 to 3 times, definitely you people will remember. You have that memory capacity, so you can remember. Mu naught I r square by 2 into r square plus x square whole power 3 by 2. So in this coil only one turn is there. If you are taking n number of turns, then this formula for n turns. So B due to current carrying circular coil, so mu naught n I r square by 2 into r square plus x square whole power 3 by 2. So this is the formula for n number of turns. This one we are going to rearrange according to our convenience. So before going to rearrange this, we came to know electric field intensity. Electric field intensity due to dipole on its axial line. If it is dipole at a distance small r, what is the electric field intensity due to short dipole means E on axial line is equal to 2 kp by r cube. So what is k means here? Mu naught means 1 by 4 pi epsilon naught. K is nothing but 1 by 4 pi epsilon naught 2p by r cube. So we will convert this formula according to this. How we are going to convert means we will see one by one. You will be getting idea. This is for short dipole. For long dipole, how they will write? 2pr by r square minus l square whole power 3 by 2 whole square, like that they are going to write. This is for short dipole we have written. Same like that, how this one is going to come, we will see. Then later we are going to compare. So in electric field 1 by 4 pi epsilon will be there. In magnetic field what will be there here means mu naught by 4 pi will be there. Therefore to get pi we will multiply and divide with pi. So mu naught n I pi r square by 2 pi r square plus x square whole power 3 by 2. So what is this pi r square we can write means area of this coil. So area of this coil is nothing but mu naught n I a by, so 2 pi r square plus x square whole power 3 by 2. Next here 4 pi we want, but here only 2 pi is there. Now multiply and divide with 2, numerator denominator. Here also we require 2 there in numerator. So mu naught 2 n I a divided by 4 pi r square plus x square whole power 3 by 2, isn't it? Now if this x is greater than r, X is greater than or X is less than or. Three cases will be there. Depending on that, we will write that formula. So, if this is the case, what will be neglected? X square will be neglected. If this is the case, what will be neglected? R square will be neglected. So, radius of the coil you should have. Without radius of the coil, you won't get circular coil. Therefore, this condition we are going to take. Therefore, mu naught by 4 pi 2 NIA divided by. So, what will be neglected now? X square will be neglected. Therefore, R square whole power 3 by 2. So, 2 will be cancelled. So, mu naught by 4 pi 2 NIA by R cube. So, if you rearrange this equation, this one only we will write mu naught by 4 pi 2 capital M by R cube. This is the magnetic field intensity on axial line. So, now what is that capital M? So, what is that capital M means? In this capital M. So, if you compare with this, here P is dipole moment. Now, here capital M is magnetic moment. Magnetic moment of this circular coil. Capital M is equal to NIA. So, for 1 ton, M is equal to IA. Current into area gives magnetic moment. Units for this ampere meter square. Dimension formula ampere current meter square L square. L square is the dimensional formula, magnetic moment. So, similar to this equation. Therefore, this is the formula if you compare. Next, from this, if you brought this point P to center of this coil, now what is the magnetic field intensity? At the center of the coil, X is going to become 0. X is 0 at the center O, if you are taking this point O. Now, how this formula is going to become means mu naught by 4 pi 2 what is capital M? NIA divided by R cube. Isn't it? Same formula you got. But what about A? Because in this there is no X. So what about A means mu naught by 4 pi 2 NI pi R square by R cube. One R will be cancelled. Therefore, you are going to get mu naught NI pi. This is cancelled 2 times means which one you multiplied? Again we are cancelling that. Mu naught NI by here 2R will be remembered. Is it visible? Mu naught Ni by 2R. This is magnetic field intensity at center. For 1 ton, mu naught I by 2R. This formula you should remember. Now, at the center of the coil, which is having only 1 ton, at the center of the coil, which is having only 1 ton, magnetic field intensity will be mu naught I by 2R. If this is the coil, at the center, mu naught I by 2R. At this point, if X is negligible, this formula. If X is also there, you should take this formula only. This formula. If X is given, you should take that formula. Okay. So, this is magnetic field due to current carrying coil on the axial line at some distance. Now, see the direction of this magnetic field. If this is the current carrying coil, circular coil, if current is passing like this, so anti-clockwise direction, then if it is going to be producing magnetic field, now how this current carrying coil will be acting as which pole? So this is the current carrying coil. Actually, we will use right hand thumb rule. So if you are taking current in the direction means thumb in the direction of the current, here it is into the board. So in between means at center, it will be outside the board. So same like that, if current is passing clockwise direction, clockwise, then Current is going to be coming like this or like this. Thumb we are going to represent. Current is coming outside. Here it is outside means here it is going to be inside. So to get this difficulty, to eliminate this difficulty, how we will take means whenever circular loop is there, we can take current with our four fingers. Current direction you can take like this. So thumb gives direction of the magnetic field. So current direction you can take like this. Thumb gives direction of the magnetic field. So both you will get same directions. You can see if you want to cross check. If thumb is like this, so here it is outside. If four fingers like this, magnetic field is outside. Correct? Both are going to be same. So radius of this one is going to be capital R. Now what is the magnetic moment of this? Capital M is equal to NIA for N turns, I into A, I into pi R square if it is circular loop. Now how this loop is acting as which pole we will see. Which pole means we will see in which direction current is passing here. In this direction. Here it is passing like this. This one clockwise. It is passing like this. Now you can join these two. Now you can join these two. Now this is acting as which pole? If current is passing in anti-clockwise direction, if current is passing in anti-clockwise direction, it will be acting as north pole for us. If current is passing clockwise, then it will be acting as south pole for us. So these are the direction. Direction if you want means outside. Here it is outside. For this direction is inside. Direction of the magnetic field is inside. What is the magnetic field at center means? Mu naught I by 2R for 1 turn. For n turns, n mu naught I by 2R. This is for full circuit. So we will learn this, but after going to exam, they may ask small portion of this. They will give an arc shape A to B is allowing I current. Then what is the magnetic field intensity at some point or center O, which is making an angle theta, they will ask. Now what is the magnetic field for this arc length which is having I current? So for this, if you want to get direction, again I said curve whenever it is there, our four fingers we can represent current. Then magnetic field is inside. So magnetic field is inside. Now what is the magnetic field intensity formula? For this very simple, 1 apple 10 rupees, 10 apples how much? So 1 apple 10 rupees, 10 apples how much? If you don't know, let us assume x. You can cross multiply x into 1, x 10 into 10, 100 rupees. Same like that for full circle. For 2 pi angle, for 1 turn I am saying, mu naught I by 2r. For 2 pi angle, mu naught I by 2r. Then for theta angle, how much is the magnetic field due to that arc? So you can cross multiply. V due to arc into 2 pi is equal to theta into mu naught I by 2r. So B due to arc is equal to how much we are going to get means theta by 2 pi into mu naught I by 2r. This is the formula for this. How they will give means they will give 60 degrees, 30 degrees, some current they will give. What is the magnetic field intensity? Like that. So if they give semicircular arc like this is the semicircular arc. So which is making, how much is making angle means, which is making 9 means 180 degrees pi. At the time, so B due to this semicircular arc is going to be pi by 2 pi. So mu naught I by 2r. Pi will be cancelled. Mu naught I by 4r. Like directly also we can do. For full circle, mu naught I by 2r. For half circle, this one we have to make it half. That is also mu naught I by 4r. So these are the directions, and if current is passing anti-clockwise, how the coil will be acting as which pole, and what are these directions, what is the magnetic field at center, and what is the magnetic field due to arc shape if it is semicircular. So 1/4 like that, any arc or curved coil we got formula. So by using these formulas how we will do problems, we will see in our next class. Thank you.